Section 8.1 covers multiplying and dividing rational expressions. So to start, when we're talking about rational expressions, we're just talking about fractions in which the numerator and denominator are both polynomials. Now, before we actually do this problem, let me show you how you can do this problem wrong. This is a common mistake. So when you see this fraction, a lot of times students tend to want to cross out these x squareds because they're the same, and they want to simplify that 4 over 8 and write an answer of 5x plus 1 over 6x plus 2. Okay, this is not how we solve these problems. We're not allowed to cross out anything that's separated by either a plus sign or a minus sign. To cross things out, they need to be separated by multiplication. So if we start this over, we look at both of these, we can factor both of these polynomials. So on the top here, this would become x plus 4, x plus 1. And on the bottom here, it would be x plus 4, x plus 2. So once we have that switched, here's our new fraction. And here, these two parentheses are separated by multiplication. And when we have things separated by multiplication, we're allowed to cross out anything that's the same. So for example, this x plus 4 on the top is the same as that x plus 4 on the bottom. We can cross those out, leaving just this part of the fraction. And that's our answer. We can stop there. Again, we can't cross out these x's because these x's are separated by plus signs and not multiplication. All right, so number 2, it looks a lot harder than it is. We have this big polynomial on the top and the bottom. We want to factor it as much as we can. So we can factor this, and we can factor this. Okay, and when we factor those, it turns into this. So we want to group as many things as we can into parentheses. And once we have it grouped, we're looking for things that are the same, because now these are all separated by multiplication. So z plus 5's cross out, z minus 2's cross out. On the top, we have 2z times z plus 4. On the bottom, z minus 1. Okay, we don't have to do anything else. You could distribute this in, but you don't have to. So just go ahead and stop there. Number 3, on the top, we have a GCF. These both have a's, and they both have b's, which means we can take out ab. On the bottom, two things that are perfect squares, separated by a minus sign, square root both of them. Remember, we're going to get two parentheses here, 5 plus b, 5 minus b. On the top, we took out this ab. We have b minus 5 left. All right, now this and this are almost the same, but their signs are different. Okay, the 5 is positive in one, negative in the other, and vice versa for the b's. So what we want to do is we want to take out a negative sign. So if we divide this whole thing by a negative 1, that negative sign is going to move out front, and both of these signs switch. So now it's negative b plus 5. If we switch the order, okay, put the 5 first and b second, that's the same thing as just 5 minus b, which means we can cross these out. Okay, and that gives us our answer. Let's do one more like that, since those tend to be tricky for students. So on the top here, we can take out a z because both of these things have a z. So at that point, we have x minus 4 on the top, 4 minus x on the bottom. Again, these are almost the same. If we switch the signs, they're going to turn into the same thing. So we take out a negative. That negative moves out front here, and both of these switch signs. Negative x plus 4 is the same as 4 minus x, which means we can cross those out. So at this point, we have negative z over z squared. Remember all your exponent rules. Here we have 1z on the top, 2 on the bottom. Bigger z is on the bottom, which means we just subtract them. Okay, our final answer is negative 1 over z. In 5 and 6, there's nothing to factor. We're just simplifying it as much as we can. When it's multiplication, we can either put these together, multiply across the top. Okay, combine these. Same thing with the bottom, combine those. But instead of doing that, I'm just going to look for things to simplify. Anything on the top can be simplified with anything on the bottom. So for example, 12 over 8, both of these are divisible by 4. So this would be a 2, this would be a 3. So I'm just simplifying things that I see. 14 over 21, 7 goes into both of these, goes into this twice, goes into this 3 times. So here's what it looks like now. At this point, we can see we have 3's on the top and bottom, 2's on the top and bottom. Cross those out. Okay, and let's look at our actual variables. So across the whole top, we have a squared b c cubed d squared. Okay, across the bottom we have this guy, and now we're just using exponent rules. So 2a's on the top, 1 on the bottom, bigger a's on the top, we're going to subtract it. Okay, b's will cancel out. Bigger c on the top, subtract them, and bigger d on the top, subtract them. Okay, so fully simplified answer, A, C, D. 6, same thing. Okay, so let's see. These are both divisible by 6, 1/3. These are both divisible by 3, 7/5. Okay, so we're here. Nothing else we can simplify as far as those coefficients. Let's put everything together. Okay, so I just went across the top, across the bottom. Okay, and then lastly, we're going to look to simplify any single variables. So the a's we can simplify, the x's we can simplify, y's we can cross out because they're the same. Okay, so 2a's on the top, 3x's on the bottom, b squared doesn't change, and the y's are gone. If we come across two fractions divided, just remember that we can always rewrite division problems as multiplication. And the way we do it is just by flipping that second fraction. So keep it, switch to multiplication, and flip this one upside down. So we would end up with this. And then once it's like that, it's just like the ones on the previous slide. Okay, so 12 over 40, doesn't matter what we're picking as long as it's 1 on the top, 1 on the bottom. So I'm going to simplify both of these, divide them both by 4, and we get 3/10. Okay, 16 over 6, divide them both by 2, 8/3. Okay, here at this point we have a 3 on the top and the bottom, cross them out. 8 over 10 is 4/5. Okay, put everything together, simplify everything we can. So a's we can simplify, b's are going to stay, x's we can simplify, y's we can simplify. Wherever the bigger one in the fraction, okay, the bigger exponent, that's where our part of the answer is going to be. So a, the bigger one's on the bottom, subtract them, b stays the same, x, the bigger one is on the top, and then y, bigger one's on the bottom. 8, same thing. Okay, we're going to switch this one, and we're going to simplify all our fractions by factoring. Okay, so we can factor all these guys using earmuffs. Okay, change to multiplication, so now we're looking for anything on the top and the bottom that are the same. So those cross out, those cross out. Okay, x plus 3's, they're both on the bottom. We can't cross them out, we're just going to put them together. 6 times x minus 5 on the top, 2x plus 3 is on the bottom, and we can write that as a single fraction squared. Okay, if you left it like that, that's fine too. Now, there are a lot of different ways that they can present these problems, and the trick is to figure out how to make it into one of the ones that we've done already. So let's say you got this one. It looks really complicated. We have fractions within fractions. But if we think about this for a second, we have top fraction divided by bottom fraction. So let's rewrite it. Okay, and when we rewrite it, we can see that this is the same type of problem that we just did on the previous slide. We're going to switch this to multiplication, and we're going to flip this upside down. Okay, I'm going to include this extra step of factoring this guy by difference of squares, x plus y, x minus y. Okay, so now we have this. We can see we have two things that are almost the same, but the signs are different. So let's take a -1 out of this top one. Okay, which is the same as x minus y. So once we do that, we have two things that can cancel here. And that is it. Okay, so, oh, no, I'm sorry. I missed that. X squared on the top, x on the bottom, bigger ones on the top, and we can subtract those exponents. So -x on the top, 4 times x plus y on the bottom. And last one, just to do one other example like this, let's change this again to a division problem. So top fraction divided by bottom fraction. Okay, we're going to switch this one upside down, and we're going to factor everything we can. So we can earmuff this. This I'm just going to expand and write it twice. This guy over here is difference of squares. And this one we can take out a GCF. 2 times 2x minus 5. All right, so fully factored, it looks like this. Okay, I have these two switched because we're changing it based on that division sign. Okay, so we switch the second one. We have it fully factored. We cross out anything we can. So x minus 2's are gone. We have a 2 on the top, 2 on the bottom. Those are gone. And that's as far as we can go. There's a lot of things left over. That's okay. We're just going to put them into one big fraction.